Everyone, and welcome. Today, we are going to dive deep into a real cornerstone of quality management in SAP, the inspection plan. You know, if you've ever wondered how massive companies achieve rock-solid, consistent quality, well, you're in exactly the right place. Let's jump right in.
Just think about it for a second. You've got literally thousands of products rolling off an assembly line. This could be across different shifts, maybe even in different factories around the world. So how on earth do you make sure the quality check on bulb number 1 is identical to the check on bulb number 10,000? And that right there, that's the core challenge, turning quality from a game of chance into a controlled, repeatable science. So here's our game plan for this explainer. We're going to start with the why, the big challenge. Then we'll deconstruct the blueprint of an inspection plan itself. We'll see how it's built by answering some key questions, look at its structure inside SAP, apply it all to a real-world example, and then we'll wrap up with why this whole structure matters so much. So, how do we tackle this massive quality control challenge? I mean, you can't rely on someone's memory or a bunch of sticky notes when consistency is everything. You need something formal, something unbreakable, something repeatable. You need a blueprint. And in the world of SAP, that blueprint has a name, the inspection plan. And listen, this isn't just a suggestion or a guideline. No, it's a critical piece of master data that dictates exactly how a quality inspection must be done. It becomes the one single source of truth for that quality technician on the shop floor. No guesswork.
All right, so let's really define this master plan. I want you to think of the quality planner as an architect, and the inspection plan, that's the detailed, down-to-the-millimeter blueprint they create for every single quality check.
So formally, this is what it is. It's a core piece of master data in SAP that a quality planner carefully sets up, and its entire job is to remove every ounce of ambiguity from the inspection process for a material, or, and this is key, for entire groups of similar materials. Okay, but here's where the real magic happens. Yeah, of course, it defines how, and it ensures consistency, but the killer feature is its reusability. Let's say you have 3 different LED bulbs, a 5 watt, a 7 watt, and a 9 watt, and they all get inspected the exact same way. You don't need 3 separate plans. Nope, you create one plan and assign all 3 materials to it. And if you need to add a new check, you change it in one place, and boom, it instantly applies to all 3. Now that is powerful. So, if you're the quality planner, where do you even start building this blueprint? Well, it all boils down to answering a series of really fundamental questions. This is the logic that holds the entire structure together. First things first, and it seems obvious, right? What are we even looking at? Is it the LED bulb itself? Is it the circuit board inside? Or maybe it's the cardboard box it comes in? We have to know. This question gets answered at the very top level of the plan, a level we call the header. This is where you forge that link between the product, the material, and the set of instructions for how you're going to inspect it.
Okay, cool. We know what to inspect. So what's next? Well, how do we organize the work? What are the logical phases of the inspection, and where physically are they going to take place?
And this brings us to the next level down, operations. Think of an operation as a logical step, like a visual check or a functional test. And what's brilliant is that you can assign each operation to a specific work center. So the visual check might happen at station QC Visual, while the electrical test happens over in the QC Elect Lab. You can see how the plan starts to organize the entire workflow. All right, now we're getting down to the nitty-gritty. Within each of those steps, what are the specific, granular details we need to check? What tools or methods are we supposed to use? And these, my friends, are the inspection characteristics. This is the most detailed level of all. So for that visual inspection operation, a characteristic might be check for superficial damage. And for the functional test operation, it might be measure power consumption. You can even specify the exact inspection method or the piece of test equipment to use. See what we did? We've gone from the big picture all the way down to the finest detail. Okay, now that we get the logic behind it, let's actually see how this builds the technical structure inside the SAP system. We're going to visualize that 3-level hierarchy we've just been talking about. It's a really simple but incredibly powerful hierarchy. You've got the header at the top, then one or more operations underneath it, and finally one or more characteristics tucked under each operation. Let's break each one down real quick.
So, level 1 is the header. This is your who and your what. It's where you link to the material number. It can also hold supplier info, which is super useful. For instance, maybe you inspect the same part differently if it comes from supplier A versus supplier B, because you know they tend to have different types of quality issues. The header lets you do that. Next up, level 2, the operations. This is the where and the broad how. It groups the inspection into logical chunks and, importantly, tells the technician where to perform them by assigning a work center. This means a technician in, say, the electrical lab can just pull up a work list of only the tasks relevant to their station. It's super efficient. And finally, we hit level 3, the characteristics. These are the absolute specifics. Each characteristic is basically a single question or a measurement. Is there damage? It's a yes or no. What's the power consumption? You enter a numeric value. This is also where you can specify the exact test equipment, which creates a perfect traceable record of which devices were used for which tests.
All right, theory's great, but let's make this totally concrete. We're going to apply this 3-level structure to our original example, the quality inspection for an LED lamp. Just look at how cleanly this all maps out. At the header level, we link our plan to the material, the LED lamp 5 watt. Simple. Then we've got 2 operations. First is visual inspection, which we've assigned to the QC Visual Work Center. Under that operation, we have 1 characteristic: checking for damage. Then our second operation is the functional test, which happens at the QC Elect Work Center. And under that, we have the characteristic to measure its power consumption. See, it's just a perfect logical flow from top to bottom.
So let's bring it all home. Why is this hierarchical structure so important? What is the big number 1 takeaway from all of this? You know, the power of this blueprint really comes down to 4 key things. You get clarity and consistency, which solves our original problem of testing thousands of things the exact same way. You get control and traceability, giving you a perfect audit trail. And finally, you get incredible efficiency. You can build a solid plan with just 1 of each level. And altogether, these create a clear, repeatable, and scalable process that is truly the bedrock of modern quality management. So it really leaves you with one final thought, right? The inspection plan is a tool for turning chaos into order. It's the difference between just hoping for quality and actually engineering it. So now that you understand the blueprint, what process or what product would you want to systematize first?